Okay, so we're looking at vector fields. And vector fields take each ordered pair within a plane, whether that be an R2 or an R3 plane, and assign a vector at that given point. So an example of a vector field might look like the following. Capital F of xy is equal to y times a unit vector I minus x times a unit vector j. And if we look at this in component form, what we have is a component, the vector having components y, negative x. Now let's suppose I wanted to sketch this vector field. And by the way, you do have a PDF file where you can actually see what vector fields look like. I think some of the most common ones we've seen are the wind velocity maps that they show over hurricane season. And typically what you'll see is a group of vectors that are moving, showing you the direction in which the wind is blowing. And the cool thing about using vectors is that not only can they show you the direction in which something is going, but they can also show you the magnitude based on the length of the vectors. So if you've ever watched the news during a hurricane or during wind season, they'll show you these vectors that are moving in different directions so you can see the flow of the air, and then you get longer vectors for where the wind is blowing harder and so on and so forth. But let's suppose we want to sketch this vector field. Now this first example is just one I'm going to show you. This is the way that actually computers wind up doing this, because of course computers can compute a lot more numbers than we can, but they just randomly just pick some values and then determine what vector is assigned at those values. For example, let's suppose I look at the ordered pair 1, 1, which is right here. So this is an ordered pair within the field, which means there is a vector that is assigned to that point. And the vector is defined using this definition here. So what that means is I'm going to have a vector that uses the y coordinate for the first component and minus the x coordinate for the second. So in this case, that's going to be the vector having components 1 for y and negative 1 for the x. So what that means is at this point 1, 1, I have a vector that goes 1 unit in the positive x direction and 1 unit in the negative y direction. So there is a vector sitting right here that is originated from that ordered pair 1, 1. And I could just come in and start picking certain values, for example, 0, 1. Again, I'm going back to this definition. And so here the y is 1 and the x is 0. So when I'm at the ordered pair 0, 1, I have a vector which goes 1 unit in the x direction and no units in the y direction, which gives me this vector here. And then I might try something like, I don't know, let's try negative 1, 1. And so that's going to give me the vector, again, going back to this rule of 1, 1. So when I'm at the ordered pair 1, negative 1, I have a vector which goes 1 unit in the positive x, 1 unit in the positive y. So I have this vector here. And then, I don't know, let's try something like, I don't know, 3, 0. And so that's this point right here. And when I put that in, of course, I'm going to get 0, negative 3. So from this point, I have a vector which is 0 in the x direction and 3 units down in the y direction. And so we start getting some vectors here in this field, but it would take us forever to get a good idea of what this looked like if we just picked random points. Again, computer programs can do this because they can pick a whole lot more points than we can. But if we needed to sketch a vector field, what is a way that we could sketch it that we wouldn't have to come in and do all of those ordered pairs? And the best way to do that is through the use of level curves. So let's go ahead and look back at our vector field here. Our vector field was defined using the vector y and negative x. And so what I want to do is to use level curves, which is going to be a lot smarter way to do this. Level curves are going to take on the form f of x, y equal to some constant. So let's go ahead and pick a couple of constants here. For example, for x, or excuse me, c, let's try that one, equal to 1. if I take and I set this equation here, and by the way, this is a rule. If I set this rule equal to 1, or the magnitude, I guess I should say that's the magnitude, right, of that thing equal to 1, well, what is the magnitude of this particular vector field? The magnitude of this vector field is the square root of each of the components squared. So it is going to be the square root of y squared plus the square root of negative x squared, or simply the square root of x squared plus y squared. So this is what the magnitude of this vector field looks like. And then we're going to take that and set it equal to some constants. So we'll start by setting that equal to 1, and I get the square root of x squared plus y squared is equal to 1. Squaring both sides, I get x squared plus y squared is equal to 1. And so what this gives me here is it gives me a level curve in my vector field, which is a circle of radius 1. So let me come in here and draw this as a dotted line. And then the vectors, I can look at then specifically the vectors that originate from points along this level curve. For example, let's look at the vectors that sit here on these endpoints, and I know what those are. That's going to be, let's see, 1, 0, 0, 1, -1, 0, and 0, -1. And remember, what I get here then is a vector that originates from each of the points that I have picked, the magnitude of which is 1. So using our rule for our vectors up here, when I'm at the point 1, 0, I get the vector which has components y, which is 0, and negative x, which is -1. So from here, I have a vector which is 0 in the x direction and points straight down 1. For at the point 0, 1, which is right here, again, looking back at my rule, I'm going to have 1, 0. So this vector is going to look like this. At -1, 0, which is here, I get the ordered pair 0, +1. So get this one here. And at 0, -1, which is this point down here, I get -1, 0. So I get this vector here. And so we're starting to get a look of what this vector field is looking like. Let's go ahead and do another level curve here. For example, let's go ahead and let c equal to 2. For c equal to 2, what we're going to do once again is set the magnitude of this thing then equal to 2. The magnitude we found was the square root of x squared plus y squared, and we'll set that equal to 2. Squaring both sides, I get that x squared plus y squared is equal to 4, and that's going to give me then a circle of radius 2. All of the vectors which originate from points along this circle will have a magnitude of 2. That's what we set it to. So let's go ahead and pick some points that make sense here along this level curve. And those points are going to be, let's see, that's 2, 0, 0, 2, -2, 0, and 0, -2. And again, for each of those ordered pairs, I can use my rule for my vector field to get the vector that originates from those points, goes in the direction indicated by this rule, and then of course have a magnitude of 2. So I'm going to get, let's see, the vector having component 0, -2. That's going to come here and go down 2. The vector having components 2, 0, so that's this one that originates here. The vector having components 0, 2, coming from here. And then finally, the vector having components -2, 0. And so what we start getting then is a much better idea of what those vectors look like in our vector field.